There's a few terms you'll hear from time to time about network architecture that probably a graphic is the best way to picture what's going on when they talk about these things. Uh, Perimeter network and DMZ, things of that nature, and what's comprised in that structure. This is a fairly decent graphic representation of a modern network. I don't know if you can see all the lines on there, but this would be your internal area right here. A firewall protecting the internal area. These are routers. And then an internal DMZ, borrows the term from the military, demilitarized zone. And then another firewall. This is a pretty complex setup for most places. Another router, and then out to the general internet. In here, in your DMZ, you can put your web servers. You might have your Barracuda spam filters, your email filters out here in the DMZ. This is known as your perimeter section of your network. It defines the border. And the best way to think about a network, I think, is as a globe. You could put another shell around a globe and have a space in between, and it's this right here. It's what protects the inside part. Here's your servers, PCs, etc. Here's your stuff you want the public possibly to get to. Email, webmail. These routes into your network and through this firewall are extremely filtered down to, the absolute minimum that you need to get into and do any work with. This could be an untrusted network too. This would be a trusted network. This certainly is untrusted out here. It's possible to have a configuration like this and have this connection wind up to another remote section of your own, which conversely could be another trusted network. There are technologies that will connect this network to another network somewhere out here, virtually and privately, in such a way that you can probably trust that one location, that network across the state. Can be done. But this is the basic. You're outside untrusted. You're inside, semi-trusted maybe. And then, you're on your DMZ, semi-trusted. And then you're inside, which would be trusted. Very tightly controlled. Routing, firewalls. Routers can offer a lot of firewall type filtering also. So that's the basic picture when you're looking at network perimeter and how this works. Now there's a couple of tools that are used pretty regularly to inspect what's going on a network and get some idea of what's happening. They could be used by testers and security professionals testing a situation. They're also used by the bad guys. They're also used by people trying to get in. And one of them, let me find it up. I should have had it. Whoops. There it is, Wireshark. This is the Windows version of Wireshark. It is essentially a network sniffer used to collect data packets. I have some internet connections going here. This is going to be a really, really quick run through. Wireshark, the use of it is in itself an entire class, I think. But it's a real common tool. Let's see, let's do some, let's start a capture. It's already capturing. These are data packets on my network that you see filling out here. I'm going to go do some. There we go. Let's see. Let's switch over to that site. Switch over to this site. Let's bump back to this site, and you can see the activity going on there. These are all data packets flying around on my network. I've paused the capture. You can see the source, my computers, my wireless, where they're going. And down here, you can actually see the contents, just the actual data contents of that data packet. Drop down to this one. There's the actual, it's all encoded. You really can't make much sense out of it right now. A lot more information up here. Source port 443, destination port. This is a secure port. That's SSL. Used to be, and I've seen examples where wireless networks had wireshark run on them, and people would log into websites over their wireless connection somewhere in a public setting, and you can look right down in here and you could read their password right there in plain text. There's all kinds of stuff here, and again, looks like I was connecting to reddit.com. I know that's Reddit traffic. I know that much. There's a lot of information you can pick up about this. Let's see what else we got here. Well, that's an interesting one. When they're in the same color, they're generally considered part of the same data stream. Here's a certificate for somebody. Some of this information is clear text. You can figure out what's going on. It's an entire certificate, so it's going to be pretty large. Here's a server hello. Again, that's a secure server. What's the word I want? Secure server. There's another client hello. It's reddit.com again. Bounces back and forth. There's a ton of stuff here. A lot of this stuff is automatic, just happening in the background. Oh, this is interesting stuff. What is this? I have no idea. It's all related. I have no idea. I'd like to look that one up. Anyhow, this is wireshark, used in tandem with some other data manipulation software. There's an incredible amount of information that can be pulled out of what's going on a network. And often professionals use these just to see what's happening on their own network. They can watch for unusual traffic. Let's see, I don't know who that one is. Oh. This is the Windows version. You can get it in Linux, but the Windows version is kind of nice. This is a real new version, by the way. When I first fired it up, I couldn't figure out what the heck the screen was saying in the front. Anyway, it's free. Just Google Wireshark, get it. Again, a huge learning curve on Wireshark. There's a lot of stuff here. There's many, many different tools. Here's some wireless tools. Here's some telephony tools, statistics. I mean, there's a pile of stuff in this. It is a very powerful piece of software. Get it and use it at home. Don't go to work and run this on your network. Don't even think about it. It is can be seen as malicious activity, especially if you're not authorized or expected to be doing something like that. That's Wireshark. Good one. It's a freebie. There's one other in the. I'm going to use Linux to demonstrate this one. There's one of the first steps in surveying a network is to find out what kind of ports are open, what kind of services are running on the various servers. It's remarkably common for people to have servers accessible via the internet that have completely unnecessary and exploitable ports open. And what do I mean by ports? They are specific slots in a network stream that specify what service you're wanting. Network. Internet. HTTP traffic runs on port 80. I know if I see anything on port 80, it's from a website or to a website. If I see stuff on port 21, I know it's FTP, File Transfer Protocol. That's how the system divides up the traffic. It's coming in on one wire, but the port numbers determine what service responds to which data packets. So there's a way to scan a network or scan a server. And if you had a whole range of servers, of course, you can put in a range of IP addresses, but you can scan particular servers and see what kind of ports they might have open, what kind of services they might be running that are exploitable. So we're going to run nmap. It's called nmap. There is a version of it available for Windows. I have not installed it. Frankly, it looked to be a pain in the butt to install on Windows. It's a simple thing on Linux. It's native to Linux. Nmap. Let's run nmap against. Let's run it against vaderot.edu. It's looking out on the network at that URL, www.vaderot.edu. And here we go. Here's the open ports and services associated with vaderot.edu's web or public face. We have FTP open. We have SMTP, that's email. HTTP, of course, a website. For some reason, I'm not sure what hosts to that in. I think that's a name server service, DNS type service. POP3, it's another email service. Secure HTTP. SNPP, Simple Network Paging Protocol. Apparently Vaderot has pagers that can get their pages over the web, over the internet. RTSP, I forget what that one is off the top of my head. I looked it up yesterday. Submission, oh look, there's a database port. Ooh, there's a SQL database port open. WMS, I ain't sure what WMS is. I have to look that one up. But it's entirely possible that you could pull a ton of useful information down and discover, holy smokes, they've got an open port. There's also a way to return operating system information. Let me look this up right quick. Let's see. Yeah, I'm going to figure out, let's see, -A. What is that option? Let's get my window bigger here so I can see what's going on. Wow, this is a complex manual. I should look this up beforehand. Let's get out of this. Let's repeat my command. Let's just do -A and see what that returns. Let's switch. I think that'll give me a lot more information. Yep, it's going to pull a lot more information down. Spending a little more time on it. That's often a case where watchful, wary network administrators will know when nmap is being run against their servers. Some servers completely block this kind of traffic. There's a lot of servers on the internet that you can't ping. I think CNN.com, I think they prevent you from pinging them. My own website, I can't run nmap on it. It's on Microsoft Azure, and they block it completely. It's kind of a good thing. Come on. Nmap's pulling a lot more information down. Where we got a result. Here's nmap, everything. Host is up, DNS records, let's see. It's Microsoft FTP daemon. See if I see anything really interesting here. Oh, a lot of the web pages. Hey, look, I'm not authorized to view that page. Okay. What's the good ones here? There's POP3, some email stuff again. There's a potentially risky method listed here. Let's see, Windows Media Server. Oh, okay. It's Windows 2003. It's interesting because support for Windows 2003 is gone. Interesting. There's a trace route. How many router hops did it go through? Nmap is fun, so I'm trying to say. You can learn a lot of stuff that's going on servers using Nmap. Look it up. It's on there. You can download versions of it for Windows. If you want to, if you have a Linux box sitting around, just yum install Nmap. Boom, it's done. And then Nmap at the command line. It's got a huge manual page. You can learn a lot about it. You can learn a lot of information about network services running on servers. All right, I'll let you go now. Okay, bye.